Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list published on July 14, 2025, just 2 days ago. This paper introduces a model that can synthesize a 4D dynamic view of a scene from a single video in just 0.93 seconds. The paper is titled MoVieS Motion Aware 4D Dynamic View, Synthesis in 1 second, and this incredible speed is a game changer for real-time applications. It's the first feed-forward framework to jointly model a scene's appearance, geometry, and motion all at once. Also, the authors have put up the official repository on GitHub. It looks like they just initialized it, so the full source code for training and inference isn't quite there yet. But they have a roadmap to add the code, pre-trained models, and dataset scripts. Definitely one to watch. Alright, so let's dive into the architecture. This first figure gives a great overview of how the MoVieS model works. It takes video frames and processes them with a vision transformer, which is a model that treats parts of an image like words in a sentence. This information goes to a central backbone, then splits into 3 heads. A depth head predicts geometry. A splatter head handles appearance for 3D Gaussian splatting. That's a rendering method using tiny colored shapes. And a novel motion head predicts movement. These 3 outputs are what create the final 4D scene. Okay, so for a model with these specialized heads to work well, it needs to be trained on a really diverse set of data. This table shows exactly what the authors used. They combined 9 different datasets, mixing static scenes from places like Real Estate 10K with dynamic, motion-focused data. What's really interesting is the repeat column. To make sure the model doesn't just get good at the biggest datasets, they duplicate the smaller ones, sometimes thousands of times. This balanced, large-scale training is what enables its impressive speed and flexibility across so many different scenarios. Moving on to the results, this table evaluates how well the model performs on novel view synthesis, which is generating new viewpoints of a scene. It compares against other fast, feed-forward models and slower, optimization-based ones. The metrics here are PSNR and SSIM, which measure image quality, higher is better, and LPIPS, a perceptual score where lower is better. The standout result is the speed, 0.93 seconds per scene versus tens of minutes for other methods. And for that incredible speed, it achieves top-tier performance on both static and dynamic datasets. Beyond just creating new views, this next table shows how well the model tracks motion by evaluating 3D point tracking. The main metric is endpoint error 3D, which is the distance between where the model predicts a point will be and its actual location, so lower is better. On all 3 datasets shown, ARIA Digital Twin, DriveTrack, and Panoptic Studio, the model, listed as hours, achieves a dramatically lower error. The other metrics measure the percentage of accurately tracked points, and here too, the model is the clear winner, showing its motion prediction is extremely robust. So, that powerful 3D point tracking leads to some really cool capabilities. This figure shows what the model can do in a zero-shot way, meaning for tasks it was not specifically trained to perform. The top row shows scene flow estimation, which visualizes the 3D motion of every pixel. You can see it correctly tracks the movement of people and even the camera itself. And in the bottom row, it performs moving object segmentation, automatically isolating only the dynamic parts of the scene. This versatility really highlights the benefit of its unified approach. So, in wrapping up, this paper presents a really powerful new framework. The key takeaway is how it unifies a scene's appearance, 3D shape, and movement. It does this using a feed-forward approach, meaning it processes a monocular video or a video from a single camera directly to a 4D output without re-optimizing for every scene. This unified design is what allows it to generate these dynamic scenes in about a second, a huge leap in efficiency. It's a major step towards general, real-time understanding of our dynamic world. That's all for this week's AI Research Roundup. Thanks for listening.